Let's look at some examples of simplifying and evaluating some trig expressions. In this first example, we want to compute the value of the sine of 67.5. Right off the bat, we should realize that 67.5 is not one of our nice unit circle values. So we could try using maybe a different identity to compute it, but unfortunately it's going to be difficult to do using like a sum or difference identity. And so what I then look at is that we have this 67.5. So we have a number with a 0.5 decimal. And so that indicates to me that that number has actually been divided by 2. That 67.5 is the result of some number divided by 2. It is half of another number. So to figure out what that number is, we could take maybe A for the angle divided by 2 and set that equal to 67.5 degrees. And then to figure out what the angle is, multiply both sides by 2. So 2 times 67.5 is going to give us 135 degrees. So I could take the sine of 67.5 degrees and rewrite it as the sine of 135 degrees divided by 2. And this looks like it's going to fit within our half angle identity. And so for sine, the half angle identity for sine says that we're going to have plus or minus the square root of 1 minus the cosine of the angle A. So we're going to have 1 minus the cosine of 135 degrees. And then everything inside the 1 minus cosine, that is all divided by 2. Now we still need to figure out whether it's plus or minus, and then we still need to simplify the insides of that radical. So whether the square root is going to be positive or negative depends on the quadrant of the original angle. So what quadrant is 67.5 located in? Well, that's between 0 and 90. So that's somewhere in the first quadrant. And we know that sine is positive in the first quadrant. So I'm going to use that positive square root. All right, so let's continue simplifying that. We know it's now going to be a positive square root. And then we're going to have 1 minus the cosine of 135. And the cosine of 135 is basically a 45-degree angle. So cosine of is going to be root 2 over 2. But technically, 135 is in the second quadrant. So we're going to have a negative square root of 2 over 2. So we have 1 minus a negative square root of 2 over 2 all over 2. The double negatives are going to turn that then into a plus. So we have 1 plus a square root of 2 over 2, and then all of that is over 2. And that is technically the exact answer. That's we could simplify it a little bit more, which we'll continue to do, but that is the actual value for this sine of 67.5. To simplify it a little further, we have several fractions in here. So we have the square root of 2 over 2, and then we have the larger 1 plus square root of 2 over 2 over 2. And so one way that we could try to simplify this is look at the bigger fraction. And if I multiply it by 1, right, we don't change what that fraction is. We don't change the value. But we do change the way it looks. And so instead of actually using a 1, I'm going to rewrite that 1 as a 2 over 2. Okay, so I'm going to take the top 2 and multiply it into the numerator of the big fraction. I'm going to distribute it to the 1 and the square root of 2 over 2. And then I'm going to take the bottom 2 and multiply it to the other 2 in the denominator. So when I distribute this 2 in the numerator, we're going to have the square root of 2 plus the square root of 2. Right? The 2 times the 1 is a 2, and then the 2 times the square root of 2 over 2. The 2's cancel, so we're left with just the square root of 2. And then in the denominator, I have a 2 times a 2, which is a 4. And then maybe one extra step we could take. When you take the square root of a fraction, you can do the square root of the numerator separately from the square root of the denominator. And so in the numerator, there's nothing I can do, so I'm going to be left with the square root of 2 plus square root 2. So we actually have a square root inside a square root, and that's fine. But in the denominator, I can take the square root of 4. and so that is going to leave me with the 2. So the sine of 67.5 degrees is going to be the positive square root of the quantity 2 plus square root of 2, and then all of that is over 2. All right, let's try another example. This time we're looking at the cosine of 5 pi over 8. Again, we could try to use like the sum or difference identity. Unfortunately, we can't find two numbers that add or subtract to 5 pi over 8 that are also reducible to unit circle values. So instead, we could also try to apply the half angle identity. In this case, we could see that we'll do the same thing. A over 2 is equal to 5 pi over 8. And if you multiply both sides by 2, then we're going to get on the left side, we just have A. And then on the right side, 5 pi over 8 times 2. The 2 and the 8 are going to reduce, so we have a 5 pi over 4. Okay, so cosine of 5 pi over 8 is the same thing as the cosine of 5 pi over 4 divided by 2. And so again, that looks like a half angle identity. And the half angle identity for cosine says, again, we're going to have the plus or minus square root. We have to figure out which of those which sign we're going to have there. So we have the plus or minus square root of 1 plus the cosine of the A angle, the angle that was divided by 2. And so in this case, that's a 5 pi over 4. And then that is going to be over a 2. So it's a very similar formula that we had before. The only difference between the sine and the cosine with the sine of half angle is that it's 1 minus cosine, whereas with cosine, it's going to be a 1 plus a cosine. We'll continue simplifying this just like we did before. So we're going to have to figure out whether the sign is a positive or negative. So if we look at where 5 pi over 8 is located, so we know the x-axis, the positive x-axis is 0, the negative x-axis would be pi, which if we wrote that with a common denominator, that would be 8 pi over 8. And then that means the positive y-axis would be pi over 2, or we could rewrite that as 4 pi over 8. And so 5 pi over 8 actually has to be past the y-axis. It has to be somewhere in the second quadrant. And we know that sine is negative in the second quadrant. So this time we're going to have a negative square root of 1 plus the cosine of pi over 4. And that's going to become 1 plus cosine of 5 pi over 4 is going to be another negative square root of 2 over 2, all over 2. So this time inside the numerator, inside the square root, the signs aren't, they're not going to cancel out. So we're going to be left with 1 minus the square root of 2 over 2. So we have the negative square root of 1 minus a square root of 2 over 2. And then all that's divided by 2. And I'm going to do the same thing. We're going to multiply top and bottom by 2. And so that's going to leave us with a negative square root of 2 minus a square root of 2, all in the numerator. And then we're going to have the 2 times 2 in the denominator, which is a 4, and the square root of 4 is a 2. So the cosine of 5 pi over 8 is going to equal a negative square root of the quantity 2 minus square root of 2. And then all of that is over a 2. And let's look at one more example. This time we're given that the sine of the angle phi, so phi is a Greek letter. There's different ways we can write it, but generally it just looks like kind of a small circle with a sort of vertical line passing through it. The sine of phi is equal to a negative 4/5, and we know that that's for some angle phi, that's going to be in the fourth quadrant. And we want to determine the value of 3 expressions: the sine of phi over 2, the cosine of phi over 2, and the tangent of phi over 2. So let's first write down what the identities are for each of these. I know the sine of phi over 2 is going to be plus or minus the square root of 1 minus the cosine of phi over 2. cosine of phi over 2 is also going to be plus or minus the square root of 1 plus the cosine of phi, and then all of that over 2. And then for the tangent of phi over 2, again, there's a couple ways that we can rewrite that tangent of a half angle. I'm just going to use the option where we have 1 minus the cosine of phi divided by sine of phi. Okay, so those are the three identities, three formulas that we could use. To actually compute these values, we need to know the cosine of phi and the sine of phi. So not phi over 2, but just the cosine of phi. Well, we actually already know the sine of phi, right? So we're told that the sine of phi is a negative 4/5. And so we just need to figure out what is the cosine of phi. Okay, there's several ways that we could do this. We know that cosine and sine are related to each other by the Pythagorean theorem, so we could do cosine squared of phi plus sine squared of phi is equal to 1. So we could just plug that, the negative 4/5 in for sine, and then we could solve that for cosine. So that's going to give me cosine squared phi plus, and in the place of the sine squared, again, I'm going to write a negative 4/5. So it's going to be a negative 4/5 squared, and that has to equal 1. So we have the cosine squared of phi plus 16/25. And I get that because it's a negative 4/5 that's being squared. So if the 4 squared and the 5 squared give me 16 and 25. So cosine squared of phi plus 16/25 is equal to a 1. And I already know I'm going to need to subtract that over, so let's rewrite that 1 with a common denominator of 25/25. So if I subtract a 16/25 from both sides, I'm going to get that cosine squared of phi is equal to 9/25, which means cosine of phi is going to be either a positive or a negative 3/5. Now, since we're talking about in the fourth quadrant, then I know cosine has to be positive. So cosine of phi is going to be a positive 3/5. Okay, so I know all the values I need. I can go ahead and plug them into my square roots or my identity formulas. We also need to look at whether or not our square roots are going to be positive or negative for the sine and the cosine. This one's not too hard, but it's a little, we have to think about this. If I'm told that phi is in the fourth quadrant, then that means that phi has to be between, we'll do this in degrees, phi has to be between 270 degrees and 360 degrees, right? So just assuming it's within the fourth quadrant of the unit circle. So phi has to be between 270 degrees and 360 degrees. If we were to divide 270 by 2 and phi by 2 and 360 by 2, well, 270 divided by 2 is going to be 135 degrees. That has to be less than or equal to phi divided by 2. And 360 divided by 2 is 180. So 135 degrees has to be less than or equal to phi over 2, and phi over 2 has to be less than or equal to 180. So an angle that's between 135 and 180 is actually in the second quadrant. Okay, again, that's assuming that this angle phi is does not go around the circle more than once. It's just it's counterclockwise with between 0 and 360 degrees. So we know that we have an angle in the second quadrant. For angles angles in the second quadrant, we know that sine is going to be positive, cosine is going to be negative. Okay, so let's go ahead and plug our 3/5 in for cosine and our negative 4/5 in for sine, and simplify our expressions. So the sine of phi over 2 is going to equal the positive square root of 1 minus a 3/5 all over 2. To simplify that, let's first combine the numerator. So 1 minus 3/5, remember 1 minus 3/5 would be the same thing as 5/5 minus 3/5, and that's going to be 2/5. So 1 minus 3/5 is going to be a 2/5, and we're still, all of that's divided by 2, and we're still within the square root. So the square root of 2/5 divided by 2, and the nice thing here is we're taking dividing by a 2 over 1, and so we could flip the 2 over 1 as a 1/2, and the 2's are actually going to cancel out, and so we're just left with the square root of 1/5. Okay, so we can say that the sine of phi over 2, for this sine of phi equaling negative 4/5 in the fourth quadrant, sine of phi over 2 is going to be the square root of 1/5. We could also rationalize that and end up getting a square root of 5 over 5. So either of those would be acceptable. For the cosine of phi over 2, we are going to have a negative square root of 1 plus 3/5 over 2. And again, for cosine, since we're doing 1 plus 3/5, again, the 1 is 5/5. So 5/5 plus 3/5 is actually going to be an 8/5. So we have the negative square root of 8/5 divided by 2. Again, that 2 is going to reduce that 8 down to 4. So we have a negative square root of 4/5. The square root of that 4 is going to be a 2. So we have a negative 2 over the square root of 5. Again, you could leave it there, or you could rationalize it, which would give us a negative 2 square root of 5 over 5. And so that's the value for the cosine of phi over 2. And the last one here is we're dealing with, again, the tangent of phi over 2, which we rewrote as 1 minus cosine of phi over sine of phi. And so if we replace the cosine with 3/5, we have 1 minus 3/5 over the sine of phi, and we know sine of phi, we are given that, is a negative 4/5. So we have 1 minus 3/5 over a negative 4/5. So to simplify this, again, let's combine the terms in the numerator. So 1 minus 3/5, that's 5/5 minus 3/5, which is going to be a 2/5 over a negative 4/5. And so we're taking a fraction, dividing it by another fraction. So let's multiply the reciprocal. So 2/5 times a negative 5/4. The 5's are going to cancel, and the 2 and the 4 will both reduce a little bit. So the 2 becomes a 1, and the 4 is going to reduce down to a 2. So in the numerator, we just have a 1 times a 1. And in the denominator, we have a 1 and a 2. So, and then we have our negative here. So the tangent of phi over 2 is actually just going to be a negative 1/2.